Hello, I'm JW. This time I'm going to have a look at fluorescent lighting. And fluorescent lighting as in the tubular form, which is a fairly short tube here, typically referred to as a 3-foot tube, although it's not actually 3 feet in length, it's commonly referred to in the length in feet. And it's got 2 little pins on each end there, that's the end there, and of course the other end is pretty much the same. And these have been available for a considerable amount of time, first in common use in the 1930s. And the technology to operate these hasn't really changed much in all that time, although of course you can get now electronic ballast and things, but in terms of the original starting method, it's pretty much the same now as it was all the way back there. Now what we've got here is this particular tube, and we've got a fitting here that it actually does go into, some manky old thing, but fairly short, so we'll have a look inside that a bit later on. And in terms of the tube sizes, this one is a T8 tube, meaning it's 8/8 of an inch in diameter, so basically it's 1 inch in diameter. Previously you could get those things in the background there, which is a T12, and that's 12/8 of an inch, or in other words 1.5 inches in diameter. Those are pretty much obsolete now as they were deemed to be inefficient, so unfortunately you can't actually buy those, or if you can it's very limited supplies, it's just what people may have left in stock. But the end connection there is the 2 pins, and it's actually the same connector on this one and the T12 as well, so in most cases you can actually just put the thinner tube into a fitting designed for the larger diameter. So let's have a look inside this particular fitting and see how these things actually work. Now what we've got here is this 30-watt tube here, 6 mounts on the end, made by Thorn, and it's white, and the number here, which is 3500, refers to the kind of white. As obviously you can get through a warm white and cold white and daylight and many other kinds. But this again is a fairly old one. They still make tubes of this length, but they're not generally referred to as 30 watts anymore. Nevertheless, the principles are the same. And as we saw there, we've got the 2 pins there on the end, and just the metal cap there, which is not actually electrically involved. It's simply the 2 pins for the electrical connection. And of course the other end is pretty much exactly the same. Now here's the actual fitting, and you can see on the end here just got the 2 holes there where those pins would fit in, and on this particular design the ends are actually spring loaded, so of course you can just move that out and then it will move in and hold the pins in position. Some of the types, particularly more modern ones, have a slot here, and you basically slot the pins in and then rotate the tube by 90 degrees to make contact, and on those the ends are fixed. The main disadvantage with this style, in that you have to pull them apart, is if you wanted to put a long row of these, you can't actually put another fitting right up against this, because of course then there's no space to actually open the thing like that. Whereas with the slot in and twist variety, you can put another fitting right up against it and then have a continuous line. But that's just a minor consideration there. Now this particular one, say, is a bit manky and corroded, mainly because it's been in some installation for many years. And on this one the cover is removed just by these spring tabs here, again making it much easier to get into for the purposes of this demonstration. So just the metal cover there, and if we have a look inside there, we've got the original label there, which just gives you instructions on how to attach it to the ceiling. So it's 240 volts, 50 Hz, and takes that 30 watt T8 tube, or 1 inch diameter tube, made in Great Britain. Again, that might give an indication as to how old this actually is. Now inside the thing we've got 2 wires here, which happen to be orange and blue, and they just go to the 2 terminals at the end here. And I have a look at the other end, and we've got 2 wires here, both of which happen to be orange in this case, and again they just go to the 2 terminals at the end. And in the middle here, just remove this, see that one of the wires from the actual contact goes via this device here, which is the actual starter. This is actually the wrong size for this particular thing, but what's inside is going to be the same. And then in the centre here we've got the choke, as it's called, or ballast in some other language. And if we just pull the wires out of here, you can see where those actually go. So from the end there we've got a single wire going all along, from one pin going straight into the terminal here on the choke. The other pin goes through that little starter thing which we saw before, and that's the one that goes all the way across to the other end into the pin there, and then the blue one, which comes back from that end, actually goes directly to the terminal block here, and that's actually the neutral connection for your power comes in. And then we've got a short brown piece from here, which is your mains input, and it goes to the other terminal of the choke. So it's a fairly straightforward sort of circuit. So mains in, comes out of the choke here, goes to one pin, comes back on the orange wire via that little starter, goes to the other pin, and then the neutral is connected to the other pin at the other end there. Now here's the actual starter, as it says on the side here. This is a fairly modern one, and you see it's actually the wrong rating. This is for a 70-watt tube, though it probably would have worked with this one when it was still installed. And of course the voltage there, single, refers to it's for a single tube, but you can get these arranged where you have a single starter which can actually do multiple tubes at the same time. And it's made in China, so again, fairly modern item. So it's got two pins here on the end, and if we get hold of this, we should be able to just remove this from the enclosure there. So again, that's just a plastic lid. And here's what's inside. So we've basically got this glass tube, and you see this has been used as it's a bit blackened inside. And this glass tube is essentially just connected straight across the two pins there. And we've also got another component here, which is essentially just a capacitor. Again, that's just across the two pins as well. Now, the thing of interest here is the actual glass tube. And so it's just got the two wires at the bottom, and those just go inside to two electrodes, one on each side. Now, this is fairly difficult to see here, but you can hopefully see we've got two electrodes there. One is basically that vertical one, and then you've got this one here, which is moving in at an angle. And the angled one is actually a bimetallic strip, similar to what's used in thermostats. And the idea here is when this strip heats up, it will actually bend, and then it will actually contact the other strip on the other side there. And what will happen then is basically those two will be connected together, as in shorting out these two pins. So what happens initially is that the contacts are not connected, and this is filled with, say, neon or some similar component. And when the voltage is applied across the ends here, this neon will glow and actually heat up. And in heating up, it will cause the metal strip to heat up as well, and that will then bend across and short out the two. And then, of course, the neon won't be glowing anymore because there's no voltage across it. It's basically just shorted out the incoming supply there. So once that's happened, the neon gas will cool and the strip will cool, and then, of course, it will gradually open. And when it opens again, of course, then it's open circuit, and if needed, the neon gas will glow again. So just connected to a supply, all that would happen here is this would glow, the contacts would close, it would stop glowing, it would cool down, the contacts would open, and then it would glow again and repeat, and so on and so on. And if you actually look at any of these when they're actually first switched on, you can often see the glow showing through the plastic cap on these, which is fairly transparent. Very much it just sort of slots over the top like that. The other component here is actually just a capacitor, only included for some degree of interference suppression. Doesn't really have any other function in there. And that's pretty much all that's in there. So literally a glass tube with some neon and a bimetallic strip. Now the other component here is this choke, and obviously it says choke on it, also called a ballast. And basically it's just a big coil of wire, and it's wound around usually some kind of iron or steel plates contained inside. And this is quite a heavy item, counts for most of the weight of this fitting. And this is essentially similar to a transformer. The only difference being it's only got two connections here. And I saw previously, one is the line coming in, and then there's just a wire that comes out. So basically just a big coil. And the deal here is that this is actually used to limit the current that flows through the tube. Because if you just connected the fluorescent tube across the mains and it was actually on, it basically will conduct a huge amount of current and then would rapidly self-destruct. So this ballast or choke is used primarily to limit the current that goes through the tube. And you can also call this an inductor because that's essentially exactly what it is. And again, these are made in different sizes for different tubes, because obviously different tubes require different amounts of current when they're operating. This one is a 30 watt, of course, for the 30 watt tube that we saw earlier. And it can also be used for 2 by 18 inch 15 watt tubes, because again, 2 15s, unsurprisingly, is 30 watts. So just basically a big coil. And the other use that it has is because it's an inductor, if you apply a voltage to this and then just disconnect the voltage, what you'll actually get is a fairly large spike of power, and the voltage will increase dramatically, but only for a very short period. So by connecting this and then disconnecting it, you'll actually get a big pulse of fairly high voltage, and that's what's used to actually start the tube conducting when the thing is first turned on. So let's just draw out the circuit there, and first of all we're going to have the actual tube itself. And at the two ends we're going to have pins like this and pins like that. And we also had that large ballast piece of equipment, or the choke there, and that's basically just a big coil of wire. It's going to have some kind of magnetic or ferrite core in there, and essentially then it's just a big coil of wire, and it's got two connections, one at each end. And we saw there that the incoming supply, so we'll call that line there, goes to one end of the choke, and then the other end comes out and it actually goes to one pin on the end of the tube like that. We also saw that the neutral coming in basically just goes straight to a pin at the other end of the tube. So in this configuration we've just got the mains applied across the tube with the choke in there, which will limit the current which will flow through it. Now if you just connected it like this, nothing would happen because the tube doesn't actually conduct electricity in its sort of default state, so we need some way to encourage electricity to flow across here. And the tube is filled with a gas at very low pressure, but even so it still needs a fairly high voltage to actually get things moving, and we also need some way of encouraging the electrons to flow inside the tube. And this is really why the starter and a couple of other bits come in. So first of all we're going to have the little starter thing which we saw, and the connections for that are simply across the ends of the tube like that. And what's actually inside the tube here are two filaments. And there's one at each end. And if you pass electricity through these, just like a filament in an incandescent bulb or whatever, then these will actually heat up. And bearing in mind that the tube here, as we saw, has two modes of operation. It's either conducting, as in those two are connected together, or when it's not conducting there's that gas inside which heats up, causes the strip to bend across. And we'll just draw that inside as a switch because that's basically all it actually is. So when the power's applied you get the neon gas in here actually heating up because you've got line coming through here via this little filament and up to this point, and then your neutral is connected on the other side. So you've got the full mains voltage across the two terminals here, and that will cause that neon or whatever gas inside to glow and start heating up. And as it heats up it will also cause this metal strip to heat, and after a few seconds the strip will bend and actually make a contact between those two terminals there. And now what we've got is that the current is coming in here via the filament here, all the way back through here, and back through there, and back through to the neutral. So the result is that these two filaments inside the tube will now start to heat up, because of course current is flowing through them, and they're generally made of tungsten with various other coatings applied to them. So now you've got filaments heating up at either end. The current is still being limited by the ballast here, so it's not going to sort of heat up and blow up or anything. But of course the current now is flowing just straight through this closed switch, so the neon gas here is now cooling down, and of course the strip is cooling down as well. And eventually the strip will cool down enough so that it will actually spring open, and then you've basically got an open circuit here, and you've essentially now disconnected this circuit which is heating up the filaments. However, because we've got a big inductor here, when you actually open the circuit you're going to get a fairly high pulse of voltage, as inductors like to try and keep the voltage flowing rather than capacitors which sort of work in the opposite direction. So opening this up you're going to get quite a big pulse of voltage, and that pulse of voltage will appear both across this switch here and more importantly across the two ends of the tube. And assuming these have heated up enough, then the pulse there is actually enough to make the gas inside the tube start conducting. Now if the gas does start conducting, we basically get the current flowing between the two ends of the tube, and because this is now conducting and is effectively showing up as a short circuit, no current is going to flow via the starter anymore, so that will just remain in the open position forever. And now all we've got is power coming in through the current limiting ballast there, onto this filament here, via the tube and out onto the other neutral at the end there. The filaments don't heat up anymore because there's no other connection here, it's just basically two wires going to a little tube full of neon. and the voltage across the tube is actually considerably less in this state, and therefore it doesn't actually cause the neon gas in there to ignite or do anything else either. And this is basically on state, and it will stay that way until the power is removed. Now if the tube doesn't actually start conducting straight away on the first attempt, then all that happens is the cycle will repeat, so the gas again will start conducting in here, the switch will eventually bend and close, filaments will heat again, and then that will obviously then start cooling and open, voltage spike across the tube, and hopefully that will be enough to get the thing conducting. This can happen several times, particularly if the starter and tube are old. And eventually, of course, it won't work at all, it will just flicker continuously until someone replaces it. Now there are a couple of other ways of arranging fluorescent wiring inside the fitting, and we're going to have a look at those in another video, but this is by far the most common type. It's just, say, a little starter there with the gas in, inductor, and then the tube itself. And when the tubes get old, the ends typically go black, because what happens after a while is that the coating on the two filaments here eventually just boils off and then is deposited on the tube, so you quite often see sort of dark deposits forming on the glass at each end of the tube. And eventually, of course, enough coating burns away from the filaments so that they aren't actually very emissive anymore, and therefore the tube will never actually start, as there's insufficient electrons coming off of these to actually make the thing conduct. This tube is not particularly old, or certainly hasn't had a lot of use, but you can see that the end there has that sort of dark band around it where the coating is starting to obviously boil off of the electrode at the end. And it's somewhat less obvious at that end over there. Now this particular fitting doesn't have one of these, but in most modern fittings you'll also find that there's a capacitor connected between the line and neutral coming in. Usually it's installed inside here, directly across the terminal block. And this is put there for power factor correction, because if you have a large inductor here, this becomes a very sort of inductive type circuit, and therefore it affects the power factor. We'll look at power factor in another video. But essentially a capacitor, although it's not quite the opposite of an inductor, it certainly is in terms of power factor correction. So by putting a suitable value capacitor here, you can actually bring the power factor nearer to 1, which is normally desirable. They'll still perfectly well work if that's not in there. It's just that it's maybe more wasteful of power, particularly in industrial or commercial environments where power is billed according to what the power factor actually is. Certainly in your house, though, that's largely irrelevant, but you'll say quite often find those are fitted inside. So that's how fluorescent tubes and fluorescent fittings actually work. So fairly straightforward. Those are normally called switch start, and they're probably by far the most common type available. And there's not really much that can go wrong with those. The usual culprits are, of course, the tube and the little starter thing itself, both of which are easily replaced. And normally you'd replace both of those. I mean, the starter is a fairly cheap item, it's like 20 pence or something. And again, the tube's only a few pounds, so generally replace both at the same time. And the other types that you can get, there's a couple of other varieties which don't have starters, but they're fairly uncommon, certainly now with the advent of electronic versions, but we may have a look at those in a video at a later date. And the very recent ones, of course, have electronic drivers inside, so it's simply the power goes in one end and the tube's connected to the other, and there's a box of electronics in the middle. If they go wrong, well, pretty much replace the entire thing. Now, the other mode of failure, which is fairly rare, is that the ballast itself will get hot and then short out internally, and that's actually what's happened to that larger fitting in the background there. And when this happens, generally it will blow the fuse or trip the circuit breaker, because far too much current will flow through there, and it quite often destroys the tube at the same time. And if that's happened again, just replace the entire fitting. In theory, you could just go and buy a new ballast, but there's not really much point, because by the time you bought that, you've already paid for 99% of the cost of the whole fitting anyhow. And if you've got a larger one, like in the background there with the T12 tube, you can, in most cases, put the T8 tube in its replacement, because the end connectors are the same. It's just that the tube is physically larger. Now, there are a couple of types of tubes where you can't do this, particularly the ones that have no starter on some of the older ones, and also that one in the background, which we'll have a look at right now. Now, of course, I said earlier that all the tubes have the standard pins on the end, and in fact most of them do, including the old T12 variety. Unfortunately, this particular one does not, and if you've actually got one of these anywhere, then it's pretty much game over when it comes to replacing the tube. Now, the tube itself is a T12, and notice that one odd factor is it's rather loose in the installation fitting there, and if we remove this end, we can see why that is. Now, as you can see, this is rather a different style of fitting on the end here, and if we just press this and turn, see that this actually has a bayonet cap on the end there, just as you would use with your normal incandescent lamps, and it's got the two pins on the top there. Now internally these are exactly the same as the other kind. You've got the two terminals here, the little filament inside, and the other end is exactly the same. But of course at the end here we have a B22 or bayonet cap there, and of course that means you can't fit the tubes with the little pins on the end because they simply won't fit. And if you thought you'd just go to the shops and buy one of these tubes, well, think again, because these haven't been made for 50 plus years. And these only existed because when these were first introduced, which was just after the Second World War, it was obviously fairly expensive to bring in new machinery and whatever to make the twin pin ends. But of course there was an adequate supply of these already available because pretty much every house in Britain used that fitting for their normal light bulbs and other things. So hence they made tubes with the bayonet cap on the end, and just stuck the bayonet holder in there on a bit of flapping wire so you could obviously remove it and change the bulb fairly easily. Inside here it's pretty much exactly the same as that smaller one, ballast there, and there is a starter in the side, but of course it's the different fitting at the end which precludes actually changing the tube on these. So if you find one of these, which is exceptionally unlikely because they haven't been made for well, 50 years plus, then again pretty much game over, you just go and buy an entire new fitting. As you see inside here, it's just got the usual little starter there, and there is the actual starter from that. It says Atlas on it, and that's for a 5 foot 80 watt tube. Also does 3 feet 30 watts and a 4 foot 40 watt, and it's made in Britain as well. And unlike a lot of the modern ones, it actually has a metal can, so when that glows up inside, you can't actually see it because, of course, metal doesn't allow the light to come through. Here's a quick look inside that fitting, and you'll see it's pretty much exactly the same. We've got the two wires going to that in there, and in the middle here we've got the power factor correction capacitor. This capacitor is actually gigantic by modern standards. The equivalent in a new one would literally be sort of about ½ an inch square, but of course at the time they were fairly large, substantial devices. And so just take that out, you can see there it's got the old engraved or stamped in metal values on the side, made in England, but so the new ones are literally hundreds of times smaller. And so it will work without that, it just means the power factor on it is pretty horrendous. Here's the choke or the ballast in this one, and this has several terminals but only 2 are used. It's basically just a common, and then you can actually pick which terminal you've got depending on the voltage that you have wherever you are. And again, this is indicative of its age, where voltages do tend to vary in different parts of the country. But again, it's just basically one terminal and then the other, say this one for 240. Little starter there, and again that's just wired in between 2 of the wires there. That red one just goes straight through and is not connected. And of course over this end you've got the other bayonet cap there. So functionally it's exactly the same, but of course you can't get these ends anymore, haven't been available for many years. And another thing to note on this particular tube is if we just rotate the tube here, you'll see there's the remains here of a black line. A lot of this has worn off, but originally this would have connected to the metal cap here and had a continuous line all the way down to the other end, and the idea being that this would be connected to earth, and this was actually used on some of the other more unusual types of starting one, which assists in spreading the discharge along the tube. So you've got basically an earth metal strip attached all the way down the side of the tube. Most of it appears to have worn off on this one, but nevertheless that's a fairly unusual feature you don't see anymore. This catalogue here is also something you don't see very often, but we may look at some of those again at a later time. So that's a look at fluorescent fittings and the most basic and in fact most common type of operation. So until next time, thanks for watching.